Sheldon. Okay, earlier in this chapter, we multiplied scientific notation. So, we did problems like 5 times 10 to the power of 6 times 9 times 10 to the power of 3, for an example. And to do these, you tell me, what did we do? What did we do for these types of problems? Kaya, what did we do?
You take that first number and you multiply, or the first like two numbers, and you multiply them, and then you take the powers of the second number and you add them?
Good. So we end up with 45 times 10 to the 9th power. Is that a good answer?
No.
Why? What do we need to do?
You need to put under 10.
Yeah, it has to be between 1 and 10. 1 and 10. So we're going to move the decimal from the end of 45 to 4. Between the 4 and 5, right? So we end up with 4.5 times 10. And it's not to the 9th because we added a decimal. We added it. So it should be to the 10th power. So yesterday, guys, the side talk. Yesterday, we started with dividing just powers, right? And what did we do to the powers when we were dividing? We didn't divide powers. We subtracted. Right? So this is what we learned yesterday, is that we subtract the powers. So that means today, instead of adding our powers, we're going to be subtracting. And instead of multiplying the first numbers, we're going to be dividing. Okay, we're basically going to be doing the opposite of that first lesson. Let's start with an example. 6.5 times 10 to the 6 divided by 7.3 times 10 to the second. You get this down, Logan?
Yeah.
Dane, you got it?
Yeah.
So if we wrote this as a fraction, 6.5 times 10 to the 6 would be on top. I want to write it in the fraction just because yesterday a lot of the problems were in fraction form. So then the second one goes underneath, 7.3 times 10 to the second. So the first part goes together and the second part goes together, right? We're going to divide the first two numbers and then we're going to subtract the second part's powers.
So would it be like 10 over 4?
So if we take the beginning and focus on that, 6.5 goes inside, 7.3 goes outside. We can't have a decimal on the outside, so we have to move it over. 73 can't go into 65. It can't go into 6 or 65, but it can go into 650. Anybody have a guess on how many? So 73 times 10 would be 730, right? So 9 would get us probably too much. I think 8 is a good guess to start. So off to the side, I'm going to try 8. 7 times 8? 7 times 8. So 58. Let's try 9. 7 times 9 is?
63.
So we'd get 657, just barely too much. So we got to go with 8. You should be doing this with me. When we subtract, we end up having to borrow a bit. So 6 and 6 and a 0. Bring down that 0 so we can keep going. 73 times what goes into 660?
9.
Yeah, 9. Okay? $657. So we get 3,
300.
which we can't go into 30, so there would be a 0, and we're gonna stop. So in our notes, we can write stop at 3 decis. No, I'm just telling you in your notes so you don't have to ask me every time. Can I stop after the second? Can I stop? You stop after 3 spaces. Okay? Okay, so when I divide, my answer is 0.890 times 10, and now I need to divide my powers, which we spent some time yesterday doing. So, what am I going to get if I divide 10 to the power of 6 by 10 to the power of 2? Sophia?
Wait, like divide them?
Yeah, if I divide the powers,
10 to the third power?
not third, because we don't actually divide and we subtract.
10 to the fourth.
10 to the 4th power, right? So we subtract 6 minus 2.
Wait, why would we subtract?
Oh, that's what we did yesterday.
Oh,
But remember when we multiplied, we didn't multiply these. We added them. We added them. Okay? Is this a good answer?
yes. Oh, it has to be.
It has to be between 1 and 10. This is not even 1. So,
Not the separate.
shh, what do we need to do? The decimal is on this side now. So which way is it going to move?
I know how to do it.
Tell me.
So then you move it to the right, and then you turn the 10 to the 4th power into 10 to the 3rd power.
Correct.
Sorry, guys.
So we get 8.9. This is between 1 and 10. And we went the opposite direction. So up here, we were at the end and we moved left. We moved left, so we added 1. Here, we were at the beginning and we moved right. So now we're going to take 1 away. Okay?
Is it okay if you write the 0 though?
Yes. Question was, can we keep the 0? Of course.
Do we have to
Whoa,
write
look.
Let's do another one.
here? You try.
3.7 times 10 to the 7th power divided by, I'm just going to put it right into the fraction form, 5.2 times 10 to the 2nd power. So we're going to take our beginning and divide them. So 3.7 was on top, that means it goes inside. 5.2 goes on the outside. Can't have a decimal, so I move it. 52 doesn't go into 37, so I have 0 on top, and I need a 0 inside to keep doing math. So 52 goes into 370. About how many times?
7.
Let's try it.
30.
That's really close. Nice. So 364. When I subtract, I get 6. Bring down the 0. Goes in 1 time. Subtract, I get 8. Bring down a 0. Goes in 1 time. When I subtract,
Didn't you say stop at 3 though?
I'm just checking. See, 8, 7, 2, 28. So I would still have another, not going to stop. I just wondered if it would. Okay. Logan, what do I do now?
Not the Thanks, Jackson.
So I got 0.711. Am I done? What do I do with the rest of this problem?
You move it to the right. You
It has to be between 1 and 10, so it's gonna have to move to the right. Shh. So it is gonna be 7.11. We're a little bit ahead of ourselves though, because we need the second part. So Logan, how do I get the second part? For scientific notation, what is the second part? What should it be?
So it should be 7 minus 2, which equals 5. And then
So it needs to be-
minus 1 equals 4.
It needs to be a power of 10. Jacob?
Is it times 10 to the power of 9?
So when we divide,
Oh my god, I'm like,
we subtract. Put this in your notes. Make sure you have it everywhere to remind you. We're subtracting these two. So Jacob, instead of 9, what are we going to get?
oh, 5, sorry.
5. And when Logan told me to take 1 away here, he was correct, which means I have to take 1 away here. So when Sheldon said it's going to be 10 to the power of 4, he was correct. Okay, I'd like you